Hey everyone, my name is Nathan Peck and I'm a developer advocate for Amazon Elastic Container Service. In this video, I'll show you how to use Elastic Container Service to break a monolithic application into microservices. We will start out by running a monolith in ECS, and then we'll deploy new microservices side by side with the monolith, and finally we'll divert traffic over to our new microservices with zero downtime. To start, you might be wondering, what is a monolith versus microservices? And why might we want to migrate from one to the other? A monolith is an application that is a single unit of deployment that handles multiple types of business capability, usually all tightly coupled. On the other hand, microservices take each core business capability and deploy it as its own separate unit, which performs only a single function. Choosing monolithic or microservice design for your application has benefits and drawbacks at different stages of a software product's lifecycle. But in general, it's often easier to develop a monolith for a new project that isn't fully fleshed out. Then, as the software becomes more fully featured, microservices allow teams to organize their code along the logic of the business in a way that allows different components of the system to be developed and scaled independently. Many companies go through this process of recognizing that their core code base is growing complex, as they begin to have issues adding new features or extending existing functionality. They realize that they need to split some of the functionality out into its own service. But this shift must be handled carefully, especially if you have customers using your application and want to upgrade your architecture without causing interruptions. So to demonstrate how to do this type of migration, let's look at an example monolithic application. This application is going to be a small REST API for a forum. So as you can see in this application, it's a typical monolithic application. It's serving a bunch of different RESTful API routes, and you can see that there's three different top-level classes of RESTful object that are being handled. There's users, threads, and posts. So this is a very typical setup for a monolith. One code base handling all three types of requests for all three features. So first, let's verify this application will run if I run it on my local machine. So we see a message that says that the server is ready. Now let's make a few requests to make sure that the server responds. So it looks like this app server is functional, but right now it just runs locally. We need to actually package it up for deployment, and that's where Docker comes in. Docker packages software into standardized units called containers that have everything the software needs to run, including libraries, system tools, code, and runtime. Using Docker, you can quickly deploy and scale applications into any environment and know your code will run there. So here's a Docker file I've previously prepared for this application. You can see that it's fairly simple. It starts from a base image that contains my specified version of Node.js. Then it has a few commands to copy my application code into the container and install external dependencies using npm. I can use this Docker file to construct a Docker container image by using the docker build command. So this command that I just typed is telling Docker that I want to run the container image in detached mode, and I want to receive any traffic that I send to port 3000 on my local host. After I launch the container, my application is once again running on my local machine, but this time it's actually running in a Docker container. I can still access the application just like I did when it was running directly on my host machine though. And you can see that there's a response just like there was when I was running the application directly on my host. So the next step is to take this application container that's running on my local machine and get it running in the cloud. First, I'm going to create an Amazon ECR repository in the AWS console. This repository will serve as a centralized place for all my container images. Each time I modify the application, I can build a container image to capture a snapshot of the entire application environment and upload it to the repository. So I see a success message that says that I've successfully created the repository, and there's a list of commands that I can use now to upload my image to that repository. Now that my repository is created, I need to give my local machine a login so it can upload to that repository. Okay, so login succeeded. Now I can tag the container image that I had built and upload it to the repository that I created. And with the Docker container tagged, I can now push the Docker container to the registry on the latest tag. Now that my image is stored in the repository, it can be pulled back down and run wherever I need to run it, including in Amazon Elastic Container Service. In order to run the container in Elastic Container Service, I have to do a little bit of setup though. I've prepared a CloudFormation template to set up a fresh VPC, a cluster of Docker hosts, and a load balancer. I'm going to launch that stack now by using a console command. So while I wait for my CloudFormation stack to launch, I can go ahead and create a task definition for my application. A task definition is simply a list of configuration settings for how to run my Docker container. This is where I tell ECS what container image to run, how much CPU and memory the container needs, what ports it listens for web traffic on, among other things. I'm going to use the console to create a task definition for the container image that I just uploaded. So I click Create New Task Definition. I enter a name for the task definition. I click Add Container. I name the container. I specify the image URL and tag, how much memory the image needs to run, and then the port that the container will receive traffic on. I click Add to add that container to the task definition, and Create to create this new task definition. Now that the task definition is created, I can launch this task definition as a service. This is basically a way to tell ECS, run one or more copies of this container at all times and connect the running containers to a load balancer. So to do this, I select the task definition, I click the action menu and click Create Service. I name my service and specify how many copies of my container I want to run. I click Next Step, and now I need to select a load balancer to put in front of my application. I'm going to select the application load balancer type because this type of load balancer is especially well suited for an HTTP REST API. You can see that it has already selected a load balancer that I created for this demo. I just need to add my container to that load balancer, and I do that by clicking the Add to ELB button. I'm going to create a new listener on this load balancer, which receives the client traffic on port 80 and forwards it to my container. I'm going to name a target group, which is going to be a list of the containers that are running across my cluster. And I click Next Step. I'm not going to configure auto-scaling in this demo. I just want to review the settings that I specified and click Create Service. So after a few minutes, everything turns green and I can click View Service to view my newly created service. I can see that there are two running tasks, which represent two running copies of our monolith container. And now you can see that they've turned green to show a running status, which means that they're up and running. These containers have been connected to an application load balancer. If I go to the CloudFormation stack that I launched earlier, I can locate the URL of the load balancer and make a request to the address of the load balancer to verify that the service is up and running. So at this point, I have my classic style monolithic application up and running in Amazon Elastic Container Service. But I'm not done yet. My goal is to take this monolith and split it up into microservices. If we look back at the base code for the monolith, you can see that the HTTP routes relating to users, threads, and posts. A sensible way to split this application up into microservices would be to create 3 microservices, one for users, one for threads, and one for posts. And here's what that code might look like. As you can see, it's very similar to the monolithic code, but instead of serving all 3 different types of RESTful services, it only serves HTTP routes that relate to one type of resources, the posts. So what I'm going to do is I'm going to repeat the steps that I did to deploy the monolithic application, but instead I'll build and deploy 3 different microservices that will run in parallel with the monolith. First up, I create 3 new repositories for the 3 services. So now I'll build and push each container image to these new repositories. Next, I create a task definition for each of these repositories and turn each of those task definitions into a running service. So as you can see, I configure the load balancer for each service to bind to a subpath of the RESTful route that is specific to that service. And once again, I see each service launched with a couple tasks. If I make some web requests to the load balancer, I can still get the exact same response that I did before. But what's happening behind the scenes is much different. If I view the listener rules for this load balancer, I can see 4 rules. There's a default rule, which sends traffic to my monolith. But above that, there are 3 other rules which divert specific paths to my microservices. So based on the priority of these microservice rules, all the traffic that matches these paths is being sent to the microservices instead of the monolith. I can actually shut down the monolith without impacting service availability. So that's what I'm going to do right now. I update the number of tasks to 0 to tell ECS to update the number of tasks and remove all of them. And I click View Service, and I'll see that my services task will disappear. As you can see, I can still send traffic to my load balancer, and all the same paths that used to work actually still work just like they did before. I have successfully migrated all my traffic over from a monolith to microservices without downtime or a single dropped request. The same approach can be applied to any application behind an ALB, but it works especially well in conjunction with Amazon Elastic Container Service because of the automated configuration of your target groups as you deploy the new services. If you want to try this out for yourself, you can follow the steps on the AWS website Getting Started/Container Microservices tutorial. Thanks a lot for watching this demo, and I wish you the best of luck in your own microservices adventures on AWS.